Take an example where we have two trains which are coming toward each other on the same track, and there is only one track. None of these, the train can move once they are in front of each other. Similar situation occurs in operating system when there are two or more processes holding some resources and waiting for the resource held by others. In this case, we have two processes, P1 and P2. Each of the process need a resource, and there is one process which already is using the resource. So in that case, there will be a problem. This is where the deadlock will happen, and the process may block each other. So let's take this the example of process 1, which is holding a resource 1 and waiting for resource 2, which is acquired by the process 2, and process 2 is waiting for the resource 1. In this case, we have the resource 1 being assigned to the process 1, and this process 1 need also the resource 2, which is already assigned to the process 2, and this resource 1, which is already assigned to process 1, is needed by the process 2. So as you can see, all the two processes are looking for both resources, and each has occupied one of the resources. So in that case, all the process will block each other until the all resources are available, so that all the processes can continue execution. So the deadlock also can be considered or compared to a traffic jam which happens. Let's take an example of this image. We have cars from this way, we have cars from this way, from this way, from this way. Then they meet in here. What will happen? So the collision will happen. So how the collision will be managed? There would be an agent. So all the cars are blocked each other. So there would be another agent which will decide how to manage or how to handle this situation. So this maybe they may decide some cars to go backward so that some may get a way to pass, and the agent will be in the charge of that. So the operating system is in charge of handling such situations. So Kaufman in 1971 has identified 4 conditions that must hold simultaneously when a deadlock occurs. There happens a deadlock. There happen a blockage of processes. What will happen? There are 4 possible situations or 4 possible ways this can be managed. One way is what we call mutual exclusion. The mutual exclusion, a resource can be used by only one process at a time. If another process requests for that resource, then the requesting process must be delayed until the resource becomes released. So in that case of mutual exclusion, only a process which have been assigned a resource will first finish so that other process can request that resource again. Another possible condition is hold and wait. In this condition, a process is holding a resource already allocated to it while waiting for an additional resource that is currently being held by other process. In this case, a process has the resource assigned to it, but it needs other resources which have been assigned to another process. So there it will wait until the resource it needs becomes available. Another condition is no preemption. In non-preemption, resources granted to a process can be released back to the system after the process has completed its task. In this way, the resource given to a process will be released back, will be given back to the system. Then the system will decide to which process that resource is going to be assigned next. Then another condition is circular wait. In this process, the system forms a circular list or a chain where each process in the list is waiting for a resource held by the next process in the list. In this case, the process will which we hold the resource will give it to the next process when it is done to use that resource until all processes get the resource and it forms a circular. Now that we understand what is the scheduler, then we are going to talk about types of schedulers. As we said, the scheduler is an operating system program which selects the next job to be executed or to be admitted to the CPU for execution. So we have three types of schedulers, namely long-term scheduler, short-term scheduler, and medium scheduler. How are they different? The long-term scheduler, this one is responsible for selecting the processes from the secondary storage device, like a disk, and load them into main memory for execution. For example, when you launch your browser, let's say Google Chrome, you find that it takes a while to launch or to load. So which means it's being loaded from the storage where it is stored, then going to the main memory. So there is a program in charge of that, of locating it on the hard disk, then load it from the hard disk to the main memory. So this in charge of this task is what you call long-term scheduler, or we simply call it job scheduler. The reason why it is called a long-term scheduler is because it executes less frequently, as it takes a lot of time for the creation of new process in the system. So basically, launching or opening, creating a new job, it's only the process which takes longer than other processes. The second type of scheduler is short-term scheduler. This scheduler allocates processes from a ready queue to the CPU for immediate processing. We also call it CPU scheduler. Its main objective is to maximize the CPU utilization. The short-term scheduler, also known as dispatcher, is the module that gives control of the CPU to the process selected by the short-term scheduler. Short-term schedulers are faster than long-term schedulers. They execute at least once every 10 milliseconds. So you can see it is very faster, and it is the one to select which process to take place in the execution. The third one is a medium-term scheduler. This one removes the process from the main memory, what we call swapping. A running process may become suspended for different reasons. For example, it needs an input and output resource, and that resource is not yet available. So that process will not remain in the CPU. So there will be a program which will remove it from the CPU, the execution or the running state, then put it in not running state. So we call that swapping. So which means the process will be suspended, and the program in charge of that is called medium-term scheduler. In order to remove the process from memory and make it space for other processes, the suspended process is moved to the secondary storage. So this medium-term scheduler will create a space on the hard disk or on the secondary storage where it keeps that process. Then when the requests or the input and output resource become available, that process which have been swapped out will be swapped in, so that can go now on the ready queue for the next execution. So basically the medium-term scheduler works like this. We have a ready queue where the process to be executed will be selected by short-term scheduler. Now, if the process in the CPU requires or send a request of input and output resource and it's not available, the process will be swapped out. Then it's going to be stored somewhere on a hard disk. Then when the resource becomes available, the process is going to be swapped in, then it goes back to the ready queue, and the CPU will take it for execution. When it completes, it will get out. Or if it is waiting, it is requests an input and output, it can be also put on the waiting queue, then from the waiting queue to the ready queue, then from ready queue to the CPU. So those are three types of schedulers, and we can compare them as follow. For the long-term scheduler, this is also called a job scheduler, while the short-term scheduler is called the CPU scheduler, and the medium is a swapping scheduler. The long-term speed is less than short-term, while for short-term is faster among the other two, and for the medium, the speed is medium in between both short and long. The long controls the degree of multiprogramming, while short provides lesser control over the degree of multiprogramming, and medium reduces the degree of multiprogramming. In long term, the process is new to ready, while for the scheduler, the process state is ready to running. For the long term, it selects processes from pool and load them into the memory for execution, While for term, short term, it selects the processes from ready to the execution, and medium, it can reintroduce the process into the memory and execution can be continued. So basically, this is how we can compare the types of scheduling. So this is all about process scheduling. We meet in the next video discussing the process scheduling algorithm. Thank you.